In this lesson, we're going to talk about the different types of media that can be used to connect different computers together into a computer network. Now, there are two different categories. There is the bounded type of media, wires basically, and the unbounded type of media, which includes radio waves and light. For this lesson, we're just going to stick with bounded media. We're going to talk about the different types of wires that can be used to connect different computers together. The first type of networking media we need to talk about is called coaxial. It's called coaxial because it uses two conductors within the single cable, and both of these conductors share a common axis. Hence we call it coaxial or common axis. Coaxial network cabling is made up of four different components. In the center is an interconductor. This interconductor is made usually of copper or copper that's been coated with tin, and it's used to actually conduct the data signals. Now, surrounding this interconductor is an insulator. It's usually made out of PVC plastic. That's to keep the signal separated so the ground doesn't touch the interconductor. Outside this PVC insulator is another secondary mesh conductor. It's usually made out of aluminum. Sometimes it's made out of copper that's been coated with tin as well. Now, this is a conductor just the same as this one. However, data doesn't usually flow on this conductor. It's just used for grounding. That's why we have this PVC insulator in between, because you don't want your ground touching your conductor. This whole assembly then is encased in a secondary PVC sheath. Coaxial cabling has a lot of advantages. It's fairly resistant to electromagnetic interference, and it's pretty resistant to physical damage. You can really twist this cable around without damaging it. However, it's got a lot of disadvantages. First of all, it's quite a bit more expensive than other types of networking mediums. And the biggest disadvantage is that it's not really supported anymore by fast networking standards. Now, before we go any farther, it's important that you understand that not all coaxial network cables are the same. There's different types, different grades. Each different type or grade has different electrical properties. That means it's critical that you use the correct type of coaxial cable for the given implementation you're using. The first one you need to know is RG58. It was used for older Ethernet networks, and it was very, very widely implemented. The central conductor of a piece of RG58 cable used a central conductor that had a coating of tin around it. It was a standard copper conductor, but it was coated with tin, so it had a silvery appearance. And it was built such that the central conductor had 50 ohms of resistance. The second one is RG59. This one, you're probably already familiar with it and didn't even know. That's used for cable TV. It uses a copper-plated steel central conductor. That in and of itself isn't so bad. The thing that makes it so you can't use it for Ethernet cabling is the fact that the central conductor is designed to have 75 ohms of resistance. I've seen folks try to substitute RG59 for RG58 to create an Ethernet network, and it works somewhat. It'll look like it's working okay, and then all of a sudden you'll have all kinds of problems with communication and dropped links. You can't use RG59 in the place of RG58. The last one you need to know is RG6. If you have a satellite TV system, you probably have RG6 cabling in your house. Now, RG6 is very similar to RG59. If you had a piece of RG6 and an RG59 cable, you probably would have a really hard time telling them apart. The difference is in the central conductor. RG6 uses a solid copper central conductor, but it also is designed for a 75 ohm resistance rating. Now, can you use RG6 to connect your cable TV service? Use RG59 to connect up your satellite? Probably, although you'll get a lot better performance if you use RG6. You also need to know about the different types of connectors that are used with coaxial cabling. Now, the connector on your left is called a BNC connector. A lot of debate about what BNC stands for. And there's two different terms. The first one is Bayonet Neil Conselman connector, or British Naval connector. Whichever one, we just call it BNC. It's used to connect older Ethernet networks using coaxial cabling. Now, the connector on your right is called an F-type connector. Generally, it's used for cable TV and satellite TV connections. It's a twist-on connector. Unlike the BNC connector, which is molded on, the F-type connector, you just screw it onto the end and it makes the appropriate contacts. Now, the one place in networking where you use an F-type connector is if you are hooking up a cable modem to a cable TV service. A lot of cable TV providers these days provide internet access through their broadband cable TV lines. This is the type of connector you'll need to use to connect to that kind of a system. Coaxial is an older technology, and it isn't used that much anymore. There is still a fairly large installed base, but it's quickly disappearing. I suspect that it's unlikely that you will have to do much with coaxial. What you really will be working with is twisted pair cabling. Twisted pair cabling is similar to the type of wiring that's used for your telephone system in your house. Twisted pair cabling is very, very widely implemented today. You'll probably be doing a whole lot of work with twisted pair cabling. It's supported by a wide variety of networking standards, such as Ethernet, token ring, etc. Twisted pair cabling is composed of pairs of copper wiring, such as you see here. This really isn't an accurate diagram because you have one pair, two wires coming out of this one particular piece of cabling. In actuality, twisted pair cabling that you're going to be working with has 4 pairs or 8 different wires coming out. But for simplicity's sake, we're drawing it with 2. This twisted pair wiring is composed of an interconnector made out of copper, and it's usually 22 or 24 gauge copper wiring. These 2 different 22 gauge copper wires with their plastic sheath are twisted around each other, and that's done for a very specific purpose. The problem with this type of wiring is that whenever a current passes through any kind of copper wire, an electromagnetic field is created around the wire, and we call it electromagnetic interference, EMI, or sometimes we simply call it crosstalk. Now, if you've ever been at home, had the TV on, and turned on your microwave oven or the vacuum cleaner, and saw a lot of static on the screen because of it, you've experienced electromagnetic interference. It's a radio signal that's being broadcast from the wire. It's not intended, it just happens. Well, the problem with twisted pair wiring is that this interference can be absorbed by the neighboring wire, which interferes or disrupts its signal. To get around that, we twist the wires together. That way, the electromagnetic fields that each wire is emitting cancel each other out, and we negate the problem of EMI. As you can see here, we have the wires twisted together. The tighter we twist these together, the less electromagnetic interference we experience, and hence, the faster we can transfer data through these wires. Twisted pair wiring has a lot of advantages. Number one, it's very flexible. It's very easy to work with. We said that coaxial was fairly flexible. Well, it doesn't even compare to twisted pair. In addition, it's extremely inexpensive. Coaxial is quite a bit more expensive. Twisted pair is quite a bit less expensive. And one of the big problems that we talked about with coaxial was the fact that modern, fast networking standards don't support coaxial. Well, they do support twisted pair. You can get very, very fast data transfers with simple twisted pair wiring. Unfortunately, twisted pair does have a couple of drawbacks. Number one, it is susceptible to EMI, both from itself, so we twist the wires together, but it's also susceptible to EMI coming from the environment where it's run. For example, one of the things we always tell folks when they're running wiring is don't run it anywhere near a light fixture, especially a fluorescent light, because there's a piece of the fluorescent light called a ballast, and that ballast puts out a tremendous amount of electromagnetic interference. If you run a twisted pair wire by that, you're going to get interference because these wires will just pick it right up. They absorb signals really easy, but another one of their weaknesses is that they radiate signals. The signals running through the wire get kind of broadcasted very weakly, but they get broadcasted out through the wire itself. And that makes twisted pair cabling susceptible to eavesdropping. If you had someone with the right equipment, they could be outside of the cable and using a special type of radio receiver actually pick up the EMI coming off these wires and be able to capture the data that's coming off. There's actually 2 different types of twisted pair wiring that you need to be familiar with for A+. The first type is called unshielded twisted pair, and that's what we just looked at here. There's a second type called shielded twisted pair. Basically, what we do with shielded twisted pair is encase the entire wire in a second shield to reduce the amount of EMI coming off the wire and reduce the amount of EMI absorbed by the wire. Now, shielded twisted pair is quite a bit more expensive, and it's less commonly implemented than unshielded twisted pair. If you see the acronym STP, we're talking about shielded twisted pair. If you see the acronym UTP, we're talking about unshielded twisted pair. There are different types of twisted pair wiring that you need to be familiar with, just like there were for coaxial. They're rated according to what's called their category. The main difference, if you were to look at the two different pieces of wiring that had different category ratings, they would look the same to you. The difference is actually their electrical properties. Basically, how tight do we twist these wires together? The tighter the twist, the faster the data, therefore the higher quality of the cable. The first type you need to be familiar with is called Category 3. When you talk to your fellow techs and you read about it in the literature, you'll probably see it just referred to as Cat 3. Category 3 is an older type of twisted pair wiring. It can support data transfers of 10 to 16 megabits per second. It's not used all that widely anymore. Instead, what we use a lot of is called Category, or Cat 5. Cat 5 will support network speeds of 100 or 1,000 megabits per second, and it's been very widely implemented. There's a newer version of Cat 5 that's kind of coming into use. It's called Cat 5e. Now, Cat 5e is an enhanced version of Cat 5, but it offers better crosstalk protection, and it can support speeds up to 10,000 megabits per second. Finally, there's Cat 6. Cat 6 is a special form of twisted pair. It's designed specifically for fast broadband communications. You need to be familiar with two different types of connectors that are used with UTP cabling. The first one is called the RJ11 jack. This is this one on the left. The RJ11 jack has 4 connectors and supports up to 2 pairs. It has a locking tab to keep the connector from coming unplugged in the back. RJ11 connectors are used primarily with telephone wiring. They're not widely used with network cabling anymore. The one that is used for network cabling is the RJ45. That's this one over here on the right. RJ45 is used for Ethernet and some token ring connections. It has 8 connectors, so it supports up to 4 pairs of copper wires. And just like an RJ11 connector, it has a locking tab to keep the connector from coming unplugged. In addition to coaxial and twisted pair, there is another type of bounded network media that you'll need to be familiar with for A+, and that is called fiber optic cabling. Now, fiber optic cabling is very different from coax or twisted pair. Fiber optic cabling transmits light signals instead of electrical signals. To do that, fiber optic cabling has a clear plastic or glass central core. It's through this central core, glass or plastic core, that light rays are transmitted as pulses, and they represent data using binary, zeros or ones, pulses on or off, just like electrical signaling can do. At the other end, or on both ends actually, of this fiber optic cabling, we have special light-sensitive devices that take that light pulse and turn it back into digital zeros and ones electrically that can be processed by the computer system. Surrounding this central glass or plastic core is a layer of cladding, and this cladding has a special job. Its job is to make sure that the light rays stay in the central core. It's somewhat reflective. So if a light ray kind of gets off and hits up here, it gets bounced back down into the center of the central core. Depending on the type of cabling you're using, surrounding the cladding are several protective layers that make sure that things don't get broken inside here. And then we have a plastic outer sheath that encases it all together. Fiber optic cabling has a lot of advantages. One of the key ones is the fact that it is completely impervious to electromagnetic interference. It doesn't use electrical signals, so EMI doesn't have any impact on it. You could run that right over top of a fluorescent light ballast and have no EMI. In addition, because it doesn't use electrical signals, you can't eavesdrop on a piece of fiber optic cabling like you could with twisted pair. The light stays in the center. It doesn't leak out as it does with an electrical signal. Because of this, fiber optic cabling supports very, very high data transmission rates for very, very long distances, much longer than can be done with a type of twisted pair cabling. Unfortunately, fiber optic cabling also has many disadvantages. The key one is the fact that it is very, very expensive as compared with twisted pair. You're not likely to see fiber optic cable go from the network backbone to the workstation itself. Some people do that, but for the most part, folks just use fiber optic cabling for the backbone and then use twisted pair to connect workstations to it. It's a lot less expensive. In addition, fiber optic cabling is not as flexible as coaxial or twisted pair cabling. It's very easy to break fiber optic cable if you twist it too tightly. In addition, you and I, with twisted pair or coaxial, can put together a networking cable. We can put the connectors on the end and plug them in and have everything work. With fiber optic cabling, that's not the case. You need special training to learn how to put the ends on the piece of fiber optic cable properly. Now, just as with coaxial and twisted pair, there's different types of fiber optic cable. The first type is called single mode. Single mode fiber optic cable transmits light as a single ray, and we call that ray a mode. Single mode cabling is used for very, very, very long data transmissions. It has a very, very thin core, about 10 microns in diameter. And because of the way it's constructed, the light stays in the center of the core. It doesn't bounce around very much. And that allows us to have very long cable runs, and it allows us to support very high data transfer rates. Oh, by the way, single mode is also the most expensive type as well. There's a second type that's used called multi-mode. Multi-mode fiber uses a much thicker core, between 50 and 100 microns. Single mode, we transmit one ray of light through the core at a time. With multi-mode, we actually transfer multiple rays of light concurrently at different frequencies. That's why we call it multi-mode, multiple modes or multiple rays. Single mode, because of the way the cable is constructed, the light tends to stay in the center of the cable. Not so with multi-mode. With multi-mode, the light likes to bounce around. To keep the light going where it needs to be, the cladding is designed to reflect the light back in at a specific angle based on the frequency. By doing that, we're able to keep the light in the cable. However, it also causes the light to get dispersed as it travels through the cable. Hence, multi-mode cables cannot be as long as single-mode cables. Just as with coaxial and twisted pair cabling, there's a variety of different connectors that can be used to connect fiber optic cabling to a network interface card or other network device. The first type is called the ST connector. It's used with single mode and multi-mode cabling. It's a keyed bayonet type of connector. You push it in and you twist it, and it keeps everything in place. It's got a ceramic ferrule to ensure that the cable is all lined up so that the light transfers through the connector properly. There's also a type called the SC connector. An SC connector is also used with both single and multi-mode types of fiber optic cabling. However, it's just a push-on, pull-off type of connector that uses a locking tab. And it also uses a ceramic ferrule to make sure that the cable is all lined up so that the light transfers through the connector properly. There's also a type of connector called the LC connector. Just like ST and SC, LC can be used with either single or multi-mode cabling. And it's a plastic connector with the locking tab. And just like the other two, it also uses a ceramic ferrule to ensure that we got everything lined up properly. The last type of connector you need to know about is the MT-RJ connector. This connector is also used with either single or multi-mode cabling. It's a plastic connector that has metal tabs to lock it in place, and it also uses the ceramic ferrule to assure proper alignment. Of these three different types of network cabling, the one you're probably going to be spending the most time with is twisted pair. So I'd become very familiar with it if I were you. It's inexpensive, it supports high data bandwidths, and it's used a lot in the industry. In this lesson, we talked about 3 different types of bounded network media. We talked about coaxial, we talked about twisted pair, and finally we talked about fiber optic.